So good afternoon all. So we'll try to do problems on maximum and minimum stresses. Okay. So please try to revise the formula somewhere. So the direct stress formula is load by area and the bending stress formula is M by Z. Okay. So let me write those formulas. So because by remembering those, so you can able to solve the problems easily. Maximum and minimum direct and bending stresses. Okay. So earlier, both the formulas individually, right? Direct stress as load by area, bending stress as M by Z. Okay. So now the maximum stress is equal to load by area plus M by Z. Minimum stress is equal to load by area minus M by Z. Okay. So with this, by remembering these two formulas, we can able to solve the problems easily. Okay. So let's do 2 to 3 problems on this. Okay. Then we can move on to the other applications where these direct and bending stresses are going to be useful in the real applications like retaining walls, chimneys, dams, masonry dams and all. Okay. So those we will discuss after completion of these problems. Okay. Right. So let's note down the problem. First one. అందరికీ స్క్రీన్ కనిపిస్తుంది కదమ్మా? Yeah, first problem. So note down the first one. So there is a rectangular strut. A rectangular strut. Strut and strut is a compression member. Okay, is 20 centimeter wide and 15 centimeter thick. Okay, it carries a load of, let us take 60 kilonewton at an eccentricity of 2 centimeter in a plane which is bisecting the thickness. Okay. So what they are asking to find the maximum and minimum intensities of stresses in the section. Okay. So this is your problem, right? So first let us draw the diagram for this problem, how it will be. Andar kanpistunda? Guys, anyone respond? Guys, is it visible?
Yes, sir.
Yeah. Okay. Okay. So first draw the diagram. So there is a rectangular strut given. The cross section is rectangle. So as it is a strut ante entama, strut is also one of the compression member. The dimension is given as 20 centimeter wide and 15 centimeter thick. Okay. So this is the center of the section. This is the center, isn't it? So now it carries a 60 load of it carries a 60 kilonewton load at an eccentricity of 2 centimeter in the plane. This is the plane. So where it is bisecting the thickness of the member. So it is bisecting the thickness ante enti. So this is the point where the eccentricity is given as 2 centimeter. Okay, and load is acting here. Okay. Okay, so this is the top view cross section, right? So I can see the longitudinal section. Okay, so this is the point where load is acting at an eccentricity of 2 centimeter, and the load is given as 60 kilonewton. Okay, so this is your strut. Clear? Right. So now let's solve the problem. So the width is given where B is equal to so here what we do is we will try to take dimensions. Width is given as 15 centimeter, depth is 20 centimeter. So you may ask me, sir, why you took D as 20 and B as 15? As I told you number of times, in any beam, okay, any beam or any column, okay, the longest dimension will be the depth of the member, and the other dimension will be the width of the member. Smallest dimension always will be the width. Longest dimension will always be the depth. Okay, na? Okay. So because that is the main purpose of providing columns also in rectangular shapes. Okay, Namma? Right. Eccentricity E is given as 2 centimeter. Load W is given as 60 kilonewton. Okay. So let's calculate the maximum and minimum intensities. Maximum and minimum intensities of stresses. Okay, first one, let's calculate the direct stress. Direct stress. What is the formula of direct stress, Amma? Load by area. What is the load? 60. What is area? 0.2 into 0.15. And 20 centimeter by 15 centimeter kada. So which is 2 mega Newton per meter square. Okay, I converted centimeter into meter. Second one, bending stress. What is the formula of bending stress? M by Z. Okay, what is M? Load into distance by what is Z? Z is the section modulus, isn't it? Okay, what is the formula? BD cube by 12, right? So what is W? 60. What is eccentricity? How much is the eccentricity, Amma? 2 centimeter, 0.02 by what is B? 0.15. What is D? 0.2 cube by 12. Sorry, BD cube by 12 is moment of inertia, right? By D by 2. So this is nothing but Z. Oh, na? Why? Because Z is equal to I by Y. I is BD cube by 12. Y is D by 2. Okay. As I told you, depth I took as 20 centimeter, right? BD cube by 12 by what is D by 2? 0.2 by 2. Right? So this answer, what is bending stress? The bending stress you will get in around 1.2 mega Newton per meter square. Okay, that's it. So one is direct stress, which is 2 mega Newton per meter square. Bending stress M by Z, M and W into E by Z and I by Y. Okay, Y is D by 2. moment of inertia is BDQ by 12. As it is a rectangular section, altogether you will get 1.2 meganewton per meter square. So hence, based on these two, calculate what is the maximum stress. Maximum stress. What is the formula of maximum stress, Amma? Direct stress plus blending stress. How much is direct stress? 2. What is your bending stress? 1.2, which is 3.2 meganewton per meter square. In the same way, calculate what is the minimum stress. Sigma minimum is equal to direct stress minus bending stress, which is 2 minus 1.2, which is 0.8 meganewton per meter square. That's it. చూడండి ఎంత ఈజీగా ఉన్నాయో. This is the way how you may come across questions in your competitive exams. Okay, like AE and AW and all. Okay, so this is the maximum stress and this is the minimum stress. Okay, so what maximum, what minimum? This is a combined or resultant అని కూడా అనొచ్చు. Resultant maximum stress, combined or resultant minimum stress. Okay, so 3.2, 0.8. So based on this, let's draw what is the bending stress diagram of the given strut. Okay, for the given strut, if I want to draw the bending stress diagram, the bending stress diagram will be ఎలా ఉంటుందమ్మా? Can anyone? What is the bending stress diagram? The bending stress diagram will be it's better to draw it here. Okay, so let me erase this so by that you can able to understand it nicely. Let me draw the bending stress diagram here itself. Yeah. What is the stress here, Amma? Which is 0.8. Kada? What is stress here? 3.2. And the bending stress diagram is this. Okay, clear? For the given strut, your bending stress diagram is this. This is a maximum and this is minimum. Okay na? Right. So this is the way how you are supposed to calculate the maximum and minimum intensities of the stresses for the given member. Okay, right. So let's do second problem. Okay, note down next one. Then after we will do another problem on different section like T section. Okay, yeah. Note down question 2. A short column of hollow cylindrical section having 25 centimeter outside dia. Okay, paiga pi and dia and 15 centimeter inside dia carries a vertical load of 400 kilonewton along one of the diameter planes 10 centimeter away from the axis. 10 centimeter away from the axis of the column. Okay. Find the extreme intensities. What do you mean extreme? And the maximum of stresses and state their nature. What do you mean nature? What do you mean calculate their nature? Nature and positive or negative. Okay. So what is its state? We have to calculate. Okay. Right. So let's draw the diagram how it will be. So what is the given this thing? So there is a hollow cylindrical circle. I mean hollow cylindrical section. Right. So which is having the outside diameter as 25 centimeter and inside the diameter as 15 centimeter. Okay. And if you see the longitudinal section of the member, as it is a hollow, should have it. Okay, this is the longitudinal section. So what is the load given, Amma? Load is given as how much? 400 kilonewton at an eccentricity of how much? 10 centimeter. Right? So there is the eccentricity given. So we don't know what is the stress diagram also. Stress diagram, let it be as a stress diagram reference line. Okay. Right. Okay. So let's write down the given data. The external diameter given as a D, which is 25 centimeter. Internal diameter, which is small d, 15 centimeter. Okay. And what else? Let's calculate what is the area. As it is a hollow, area will be pi d square by 4, which is capital D minus small d power 4. Kada? Pi by 4, 25 square minus 15 square, which is 314.2 into 10 power minus 4 meter square. Okay. So that is your area. And the load is given 400 kilonewton. Eccentricity is given 0.1 meter, which is a 10 centimeter. Right. And let's see what is the maximum and minimum stresses. Okay. What is the maximum and minimum stresses? Minimum stresses. First one, direct stress. Sigma D is equal to W by A. What is load, Amma? 400. What is area? 314.2 into 10 power minus 4 into 10 power minus 3. Okay. And the final answer is 12.73 mega Newton per meter square. Okay. So this is the direct stress, and next one is bending stress. Bending stress is M by Z W into E by Z. Kada? Okay. What is M? M is nothing but moment Z. So again, what is Z? I by Y. What is I here? I is the moment of inertia. The pi d power 4 by 64 kada. D power 4 and as it is a hollow 25 power 4 minus 15 power 4. Pi d 4 by 64 by what is D by 2? 25 by 2. Okay, that's it. So this is I. This is Y. From this you can calculate Z, which it is coming around 1335 into 10 power minus 6 meter cube. This is your Z of your hollow section. Substitute this value here. 400 into 0.1 by 1335 into 10 power minus 6 into 10 power minus 3. Because 400 kilonewton kada, converting that into, okay. So the final bending stress is 29.96 mega Newton per meter square. Okay. Yeah. And see the maximum stress. Maximum stress and the which is direct stress plus bending stress 12.73 plus 29.96, which is 42.69 mega Newton per meter square. Right? And what is your minimum stress? Minimum stress, direct stress minus bending stress, 12.73 minus 29.96, which is minus 17.23 mega Newton per meter square. Right? So here one is positive, other one is negative. That is what he is asking. What is the state of the stress? So as positive, what is the positive indicates somewhere in our notation? What is positive indicates and what is negative indicates? Chapandi? Positive indicates what? Positive indicates compression, negative indicates tension in the zone. Okay. So based on this maximum and minimum stresses, let's draw the diagram. Okay. So your maximum bending stress is this much, and the minimum bending stress is which gone to negative in the, okay. So both like this. Okay. So this value is how much? 17.23. This is 42.69. Right? So this is your stress. Your bending stress became negative. Okay, sorry, your stresses became negative, positive to negative. And so there is a reversal of stress happened for this. Okay, negative stress, positive stress, rendu develop ayyayi. So reversal of stresses happens in this particular problem. Clear? So this is how you are supposed to solve for a hollow sections. Okay, in the rectangular section chusaru. Now we have solved one hollow circular section, right? Now we will do one problem on T section, right? So where T section in the sense which gives more picture on calculating the stresses for one unsymmetrical section, because T is an unsymmetrical section towards x-axis or y-axis. T section. T section is unsymmetrical towards which axis, Amma? X axis. T section is symmetrical about Y, unsymmetrical about X. Okay, note down this problem. Note down this problem. Third one, a column of T section shown in figure is subjected to a load of 100 kilonewton at a point on the centroidal axis. Okay, for 40 mm below the centroidal x axis. So there is a point load. See, you can clearly observe here P. P is the load which is acting on the centroidal axis. Because why is the centroidal axis here? Because as T is T is a symmetrical section towards Y. So your load P is acting within the symmetrical plane at a distance of 40 from the centroidal axis. You don't know what is the centroidal axis with respect to X. You have to calculate that. Then only you can represent X. From that centroidal point, below 40 mm, there is a load. Calculate the maximum and minimum stresses induced in the section. For the given T section, you have to calculate what is the maximum and minimum stresses. Okay. So as it is also a column, which is a T-shaped column. Okay, na? For this kind of things also, they're gonna ask you to calculate the maximum and minimum stresses. Okay, there is a T section of 200 mm by 20 mm and 180 mm of depth and 15 mm of the web width. Okay, na? Okay, let's solve the problem. Load is given as 100 kilonewton at a distance of 40 mm from the center. Okay. Yeah. So this is the problem given, right? So there is a T section, right? For this, first what we have to calculate, what is this distance. Centroidal distance calculate cheyali, avuna? Okay. From the bottom, what is this distance? If you can able to calculate this, okay, so this distance will use the centroidal plane. Okay, y value ento kavali naku. Okay. Yeah. First, let me take two parts. So this is as the first part and this is as the second part. Top flange is as the first part, bottom web is as the second part. Okay. Part 1. Calculate area. A1 is equal to 200 by 20. 4000 mm square. A1. And what is centroidal distance of this flange? Ee flange yoka center distance endamma? 20 by 2, half of the distance. Kada? But we are calculating, what we are doing? We are calculating centroidal distance from the bottom of the flange. From the bottom, what is the centroidal of the flange? From the bottom, ikkad nunchi ee center ki distance entamma? 180 plus 20 by 2. Kada? That is what y1. 180 plus 20 by 2, which is 190 mm. Okay, that is the part 1. Part 2. A2 is equal to A2 and area of the bottom web. What is the area of the bottom web? 180 into 15, which is so much. Y2. What is the centroidal of the web from the bottom? 180 by 2. మీ అందరికి తెలుసు కదా these calculations. 90 mm. Okay, so you got this, and calculate the centroidal distance. Centroidal distance y bar is equal to a1 y1 plus a2 y2 by a1 plus a2. 4000 into 190 plus 2700 into 90 by 4000 plus 2700. What is centroidal distance? Calculate this. You will get around 149.70 mm. Okay, so this distance is 149.70 is the centroidal distance from the bottom. Okay, and what will be this remaining distance? The remaining distance ఎంత ఉంటుందమ్మా? Overall distance is how much? 180 plus 20, which is 200. 200 minus this. 200 minus this. How much? 50.30. Andana? So 50.30 is the other part of the distance, right? Okay. So now, after calculating the centroidal distance, we are supposed to calculate Z. Kada? Why? Because for the direct and bending stresses, you should know the direct stress, which is load by area. What is load? How much is the load given? Load and the charma 100 kilonewton. 100 kilonewton by what is the area? What is the total area, ma? 6700. Okay, this is your direct stress. Okay, and what is the bending stress? For calculating bending stress, M by Z, you know M is P into E. Z you don't know. Kada? What is Z? Z is nothing but I by Y. Okay, Y you know. What is the Y value? Y value you got 149.70 as a centroidal distance from the bottom of the section. What is I? I is the moment of inertia. So you have to calculate the moment of inertia, right? Okay, I think you all know how to calculate the moment of inertia. Let us calculate moment of inertia for the part 1 and part 2. Part 1 moment of inertia, I plus A into Y square. What is I? BD cube by 12. What is B? 200 into 20 cube by 12 plus 200 into 20 into what is Y? From the bottom, the distance is, what is the centroidal distance amma? Ikkad nunchi distance enta? 180 plus 10, 190. 190 minus what is the centroidal distance of the first part? 149.70. Understand? So 190 is the centroidal distance of the first part minus centroidal distance of the whole section, right? So this is the moment of inertia. How much? First moment of inertia 6.620 into 10 power 6 mm power 4. Okay, and second part, moment of inertia of the second part, I plus A into Y square. What is I of the second part? B anthamma 15, D anta 180, BD cube by 12 plus 180 into 15 into 149.70 minus what is the centroidal distance of the web? Central distance of the web anta 180 by 2, 90. 149.70 minus 90 square. Okay, What is this moment of inertia? 16.91 into 10 power 6 mm power 4. Okay, add these two, your overall moment of inertia is equal to, you will get around 23.539 into 10 power 6 mm power 4. Okay, so substitute this moment of inertia here, okay, for getting your section modulus. 23.539 into 10 power 6 by what is y? 149.70. Okay, this is your section modulus, right?